Alright, so an electric circuit contains three capacitors in a particular arrangement. The given equation relates the equivalent capacitance C of the arrangement to D, E and F, the capacitances of the individual capacitors. Which equation correctly gives C in terms of D, E and F? This is the question of equivalent expressions. This has nothing to do with physics or the capacitors. Although this is, I remember doing this topic in my 10th or 11th grade when capacitors are arranged in parallel. Then to find out the equivalent capacitance, this is the formula that we use. Now, here now this is the value of 1 over C. Right? This is the value of 1 over C, and we have to find out the value of C. Now, I have seen that some students make this mistake that they simply take the reciprocal. They simply take the reciprocal on both the sides. Now, when you take the reciprocal on the left hand side, so reciprocal of 1 over C will be C, that's correct. But then they take the reciprocal of the right hand side, then they just simply take the reciprocal of each term separately. So 1 over D becomes D, 1 over E becomes E, and 1 over F becomes F, and they select the first option. And the test makers are really smart. They know that students are going to make this mistake, and that's why they put the very first option as what the students are going to do. But this is not how we take the reciprocal. When you have multiple terms, you cannot simply take the reciprocal like this. What you need to do is we need to do some simplification. So these are what? These are fractions. 1 over D plus 1 over E plus 1 over F. Now, how would you add three fractions? We make the denominator same, right, by multiplying the numerator and denominator by something. So that's what we will do here. So how can I make the denominator same for all of these three fractions? So the first term, I will multiply it by E and F, the denominator, and even the numerator I will multiply by E and F. So I will try to make the denominators equal to D, E, F. So if I want to make the second term, denominator of the second term D, E, F, we already have E. So I'm going to multiply it with D and F. Same thing with the numerator, multiply it with D and F. In the third term, F is present, E and D are missing, so we multiply it by E and D. Same thing with the numerator, E and D. So now we get EF over DEF plus DF over DEF plus ED over DEF. So now the denominators are same for all the terms. Now you can finally add the numerators. So you'll get EF plus DF plus DE over DEF. So this is still the value of 1 over C. Now you have to find out the value of C. So now finally you can take the reciprocal of the right hand side as well. So now we'll take the reciprocal of the entire equation. So you get 1 over C becomes C, and this term becomes DEF over EF plus DF plus D, which is option D.